So in this video, we're going to be talking about rewriting logarithms as exponentials and exponentials as logarithms. And this should be a pretty quick video as this is a pretty easy topic to understand once you can wrap your head around it. So in broadly speaking, logarithms, essentially, if you see one like this, it's structured like this, log, this b represents the base, log base b x equals y. And the idea is, the purpose of logarithm, it's saying, well, b must be raised to what power to get x? B must be raised to what power to get x? And the answer is just, well, it must be raised to y to get x. And a quick way of doing this, if you're doing a test or something or doing your homework, there's honestly a really quick way of doing it. You don't have to think about it too deeply. One way of doing it is you simply just you start at this b, okay, and then you do this swoop method where you start at b, you swoop around, you basically pass y, and then you hit x. So then you write it in the order that this green arrow went. It started at b, then you raise it to y, and you set it equal to x. And that's all there is to it. So if you wanted to rewrite this logarithm as an exponential function, you could simply just use this swoop method. So you would go b raised to y equals x, and that's all there is. If you're doing it the other way around, if you have x to the y equals z and you want that as a logarithm, well, it's kind of the same idea. So basically, this exponent is definitely going to be your answer. That's going to be what's on the other side of the equation. That's going to be y. So you would start at x and you say log base x of z equals y. And so again, it's like another swoop method. So, you write it in the order you did. So so I hit x first, x, then I hit z, z. So I'll write that z a little bigger, and then equals y. Likewise here, going back just for a quick second, I hit b first, and then I hit y, so b to the y, and then I hit x, so b to the y equals x. And that's all there is to it. That's how you go back and forth between logarithms and exponentials. And this can be done with this can be done pretty easily because logarithms and exponentials are just inverses of each other. So now let's just try a couple of examples. And these should be, we should be able to breeze right through these. Okay, so if I have log base 11 of 121 equals 2, and I want this in exponential form, I want this as an exponent. So I'd say, okay, well, let's do the swoop method. Let's do the swoop method. So, I start at 11, pass 2, and then I hit 121. So then, okay, I start at 11, and then apply the 2, and I set it equal to 121. And that's it. And you can even think about it. What is this asking? What is this saying? Well, this is saying, well, 11 must be raised to what power to get 121? And the answer is just 2. If I had just said log 11 121, how would we solve that? Well, you would just think to yourself, well, 11 raised to what gives me 121? And it's just 2, because 11 squared is 121. And that's exactly what I wrote down here. So if you were just asked to rewrite this logarithm in terms of an exponent, then you would just do the swoop method, or you can think about it logically, like, well, 11 squared equals 121. So let's try another one now. Let's try log base 7 of 49 equals 2. Okay, so again, we can do the swoop method. So we start at 7, we hit 2, and then we hit 49. So then I get 7 squared equals 49, which makes sense because 7 times 7 equals 49. Hence 7 squared equals 49. I'm just going to kind of draw a little separated line to divide these up. Okay, so let's do one more example that's a little more complicated. Let's try log base 216 6 equals 1/3. Okay, well, again, the swoop method still applies. Even though this is a little messy, we're dealing with bigger numbers and a fraction, the same rule still applies. So 216 to the 1/3 equals 6, just by doing the swoop method. The swoop, and we're done. And this makes sense because if you have a number raised to a fraction, if I have like 216 to the 1/2, that's the same thing as the square root of 216. If I have 216 to the 1/3, well, that's the same thing as the cube root of 216. And the cube root of 216 just happens to be 6. So this makes sense. So this makes sense right here. So those are some examples where you're rewriting logarithms in exponential form. So now let's try some the other way around. So let's just try a couple where we are converting from exponential to logarithms. So let's say I had 81 to the 1/2 equals 9. Okay, so again, we're doing the swoop method. So we start at 81, hit 9, go to 1/2. Start at 81, hit 9, go to 1/2. So okay, so I write my log. 81 was the first thing I hit, so that's my base. Then I hit 9, and then I hit 1/2. So log base 81 of 9 equals 1/2. And you can even check this too, just by doing the swoop method again. 81 to the 1/2 equals 9. And remember what 81 to the 1/2 is saying. That's saying the square root of 81 equals 9, and that's just saying 9 equals 9, which is a perfectly valid statement. So that makes sense. That makes sense. So that's basically how you do it, and I'll just box this answer really quick. So now let's try again. So let's say I had, I don't know, 7 squared equals 49. Again, we're being asked to convert from exponential to logarithmic. So I would say, I do the swoop method, so I hit 7 first, hit 49, go to 2. So I have log 7 of 49 equals 2. And that's it. You can even check that, you could do 7 squared equals 49, which is exactly what we started with. That's the exact same we started with. Okay, so let's try a couple more. So let's try a more broad example where basically we're dealing with variables in this case. So again, we're going to go back to logarithms really quick. So log x 191 equals y. So even though there's variables in here, the swoop method still applies. So I have x, hit y, hit 191. So I have x to the power of y equals 191. So the swoop method still applies. So that means x raised to what power gives me 191? X raised to y gives me 191. Okay, so let's try another one. Log base 5 of x equals 19. Swoop method still applies here. So 5, hit 19, hit x. So I have 5 to the 19th equals x. And that's going to be some gargantuan number, which I don't even want to compute. Okay, so let's try some more broad examples, ones with variables, except where we're starting with an exponential and we're converting to logarithmic. So let's say I had x to the y equals 178. Well, again, we do the swoop method, still applies. So we start at x, hit 178, stop at y. So the first thing I write, log base what? Log base x of 178 equals y. And that's it. So that's the swoop method for that one. And we'll do just one more. We'll do one more. So let's say I had 1/5 to the x equals y. So this one, we're dealing with a fraction, no different. Swoop method. So I start at 1/5, hit y, stop at x. So I get log base 1/5 of what? Of y, and it's equal to x. So it's always going to be equal to whatever your exponent is. That's the golden rule. The exponent's always going to be on the right-hand side. Okay, so now we just got to do a couple more. Let's say we were asked to we were asked to basically solve for logarithms. So let's say I had log base 4 of 64. So, what if I was asked, I was just given this and I wasn't given what it's equal to. I'm not asked to rewrite it. I just want to solve it. So what I would want to do is I want to think to myself, well, 4 raised to what power gives me 64? Well, 4 to the first gives me 4. 4 squared gives me 16. and 4 cubed gives me 64. So the answer to this is just 3. Because remember what this is saying. It's saying 4 raised to what power gives me 64? And the answer is just 3. So I would just circle this 3 right here. Okay. And then to keep this video short, I'm gonna jump ahead and do some more examples and talk about when you have a logarithm as your exponent in my next video on logarithms. So stick around for that.